Today we're extending our Open vSwitch Layer 3 lab by adding a brand new host and turning the OVS bridge into a fully functional software router. So this is a great way to see how the OVS handles real Layer 3 forwarding using OpenFlow rules instead of relying on the Linux kernel routing table. So let's walk through the whole flow step by step. So we start by creating a new network namespace called H3. So this is going to be our host living in the 10.0.2.0/24 network. So just like before, we build a veth pair. So one end goes into the namespace as veth3 and the other end, veth3-br, stays outside so we can attach to the OVS bridge. So inside H3, we assign the IP address 10.0.2.10. We bring up the interface and enable the loopback device. So on the outside, we bring up veth3-br and add it to the bridge. So at this point, our topology now is H1 and H2 in the 10.0.1 network, and then H3 living in the 10.0.2 network. Before we get started, note that OpenFlow does not eliminate ARP or routing protocols. It simply gives you the option to replace them with your own logic, and it does this with OpenFlow tables. So this allows you to program the forwarding plane directly, and this gives you complete visibility into how packets move through the switch and how OVS implements routing at a very low level, and we're going to do that exactly right now. Next, we give the OVS bridge its layer 3 identity. Here we assign 10.0.1.1 to BR0 for the first subnet, and then 10.0.2.1 for the second. So these are the default gateways the host will use. So even though BR0 is technically a switch, we're treating it like a router by giving it multiple IP addresses, one per subnet. Now we jump into routing, so host H1 needs to know how to reach 10.0.2.0 network, so we add a route pointing to 10.0.1.1, and H3 needs to route back to the 10.0.1 network, so we point it to the 10.0.2.1. So at this stage, the hosts are ready to send traffic across the subnets, but OVS itself still doesn't know how to forward anything, and this is where OpenFlow comes to play. Before we stall new flows, we wipe the slate clean by deleting any existing entries on BR0, and then we start building the routing pipeline. So the first rule is simple, it just handles ARP, so we must match ARP packets and flood them. This keeps address resolution working across the topology. The next rule matches all IP traffic and submits to table 1. So table 1 is where the actual routing logic lives. Inside table 1, we create two key flows. The first one matches any IP packet destined for the 10.0.2 network, and when OVS sees that, it rewrites the Ethernet destination MAC to the MAC address of H3, sets the source MAC to the router's MAC, and sends the packet out veth3 port. So that's the core of layer 3 forwarding. Rewrite the MAC, pick the right output port, and push the packet on its way. The second flow handles traffic going in the other direction from the 10.0.2 network back towards 10.0.1 network. So it performs the same MAC rewrite, but this time it uses the MAC address of H1 and outputs the packet towards veth1. So with these two flows, OVS now behaves like a router, forwarding packets between the two subnets based entirely on OpenFlow rules. Once the flows are installed, we can run a few show commands to confirm everything looks correct. So using the OVS vsctl show, we verify that all ports are attached to the bridge. And with the OVS ofctl dump flows, we check that the ARP rule, the IP resubmit rule, and the two routing flows are all present. And the OVS dpctl show, we confirm that the kernel data path sees the correct interfaces. We also check the IP addresses and the routing tables inside each namespace to make sure everything is consistent. Next up, let's visualize how vSwitch processes traffic through its OpenFlow pipeline. So at the center, we have our OVS switch, the 3 hosts connected using simple veth based links. And as packets enter the switch, they're classified in table 0, matched against the flow rules, and forwarded through the pipeline based on actions like output, modify, or resubmit. So each table in the scene lights up as packets move through it, giving you a clear step-by-step view of how OVS makes forwarding decisions. So this animation ties together the topology, the tables, and the packet path, so you can see exactly how OpenFlow logic plays out inside the vSwitch. Now it's time to test. So from H1 we ping the 10.0.2.10, which is the IP address of H3. So if everything is configured correctly, the ICMP packets will leave H1, hit the OVS bridge, get routed through table 1 and arrive at H3. Then we do the reverse test by pinging from H3 back to H1. So successful replies in both directions confirm that our layer 3 forwarding path is working exactly as expected. So to wrap things up, we run packet captures to watch the routing happen in real time. So capturing on veth1br shows packets entering and leaving the 10.0.1 network. Capturing on veth2br shows the same traffic as it moves through the 10.0.2 network, and capturing inside the H3 namespace lets us see the packets after OVS has rewritten the MAC addresses. So these captures make it crystal clear that OVS performing the routing logic exactly as defined by our OpenFlow rules. So by the end of this demo, we've completed a layer 3 forwarding setup using vSwitch, static routes, and explicit OpenFlow entries. It's a great example of how OVS can act as a programmable router, handling ARP, IP classification, MAC rewriting, and next hop forwarding, all controlled through a transparent, customizable flow pipeline.